one, we want to solve an equation involving a radical form. Solve an equation, we want to find the value of x. So what can we do? How can we get the x by itself? I cannot. Well, you want to move to over there and then it will be able to see better. How can we get rid of the radical on the left-hand side? Any suggestions? We can square both sides maybe. So if I square both sides, then what would that become? We will have 2x plus 1 equals to 13 square. So we have no more radical, and then we will get the 2x plus 1 equals to 13 times 13, 169. And then we minus 1 from both sides, then we will have 2x is equal to 168. Divide both sides by 2. Finally, we will get x by itself. X will be equal to 84. So does it mean that x is equal to 84? Don't jump to the conclusion so fast. What do we need to do? We need to check because this is an equation involving a radical form. Even though the question didn't ask you to do so, you need to check. So if you don't check and somehow the answer is 84, you just accidentally bump into the right answer. You need to check your solution. So you have the radical 2x plus 1 equals to 13. Standard procedure. Replace the x by 84 and then put the question mark on top of the equal sign. You're asking a question. Is that true that the left-hand side and the right-hand side are the same? And so you got the radical 168 plus 1. Is that equals to the right-hand side? And then you got the radical 169. Is that equals to the right-hand side? And finally, the left side is 13 and the right side is also 13. So you give it a check. So therefore, what would be the solution? The solution is 84. Now the solution is not 13. That is a very common careless mistake. The solution is 84 because I check my answer. Number 2, I got an equation involving a radical form. First, let's try to get rid of the radical. So what do we supposed to do? We square both sides, and then we will have x squared minus 17 equals to 8 squared. Now 8 times 8, which is 64. Isolate the x squared, so I add 17 on both sides. So we add 17 on both sides. Once we do that, then we have x squared is equals to 81. And so x will becomes square root of 81. Is that right? I'm asking, is that right to say x is equal to radical 81? Are you sure? Some say yes, some say no. What do you think? How many of you think this is yes? How many of you think this is no? So what about the rest? Something wrong over here. What's wrong? For those who say no, what's the problem? Whenever you take the square root on both sides, what do you need? It will generate a plus or minus sign immediately. And the radical 81 will be, what is radical 81? 9. So x is plus or minus 9. So how many answers do you have this time? You have 2 possible solutions, and you need to check it. Okay? You need to check x is equals to negative 9, let's say, and then you have x squared minus 17, radical x squared minus 17 equal to 8. And then the radical x, replace the x by your proposed solution, and then put a question mark on top of the equal sign. And then continue. The radical 81 minus 17, is that equals to 8? So radical 81 minus 17, that will become a radical 64. Is radical 64 equals to the right-hand side? The answer is yes. So that means x indeed is equal to negative 9. So how about the other solution? Does it mean that we need to reject the other solution? Does it mean that we should accept the other solution? No, we need to check the other solution also. And the checking process would be the same thing. Okay, now I'll let you finish the rest. But we need to check x equals to 9 also. And then turn out at the end, the solution will be, now you're supposed to do that, dot, 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 right? The solution, yes, negative 9 and 9. Both of them we are going to accept. All right. All right, now let's take a look at the next one. And we want to simplify this complex expression, complex form. Complex variable, we have the complex variable I. We have 9 minus 4i over 5 plus 7i. How can we simplify this complex number, make it becomes a plus bi form? What do we need? We need to multiply what? Both top and bottom by 5 minus 7i. Very good. This is actually indeed the conjugate. So that on the bottom, we will have 5 squared plus, so minus 7i squared. We have the a plus b times a minus b. And then on the top, you have something like a binomial times a binomial. So we distribute them one by one. 9 times 5, 45. Minus 9 times 7, 63i. Minus 4i times 5, 20i. Plus 4i times 7i. So it's 28i squared. We need to adjust something. What do we need to adjust? The line, because the 28i squared is scary, it's falling down. So let's support it. Extend the line. Let's continue. We have 45 minus 63i minus 20i plus 28i squared. Now let's work on the denominator. It would be 25 minus 49i squared. Sometime when you get familiar with this, you might want to skip the middle step and merge two steps together, and then work on the top and work on the bottom at the same time. And now let's see, I square, what is that supposed to be? I square means what? Would that be 1? Negative 1. I is equal to radical negative 1. So I square has been defined as negative 1. So in another word, I have 45 minus 63i minus 20i minus 28. And then the whole thing divided by 25 plus 49. Now let's combine the like terms. We have 45 minus 28. So what would that be? That would becomes 17 minus 83i. The whole thing over 74. Okay. Now, but the question asking us to make it becomes the a plus bi form. So we need to do a little bit more. Separate them, make it become 17 over 74 minus 83 over 74i. So we can quickly identify which one is the A and which one is the B. Take a look at number 4. Very similar. We have the 7 plus 4i over 9 minus 6i. You want to try it out a little? I catch you in 30 seconds. All right, 30 seconds is up. So let's see. We are going to multiply both the top and bottom by what? 9 plus 6i. Very good. The conjugate. So let's see what would that becomes. On the top, we are going to distribute them. 7 times 9, 63. Plus 7 times 6, 42i. And then 4i times 9, 36i. And then plus 24i squared. And the bottom would becomes 81 minus 36i squared. But we know I squared is indeed negative 1. So it would becomes 63 plus 42i plus 36i minus 24. So everything stay the same except I taking care the I square. So now it would becomes 63 minus 24. So that would becomes 39. Am I correct? Plus 78i over 107. Is that right? So far so good? Something wrong? What's wrong? What is that? 117, right? It's 117. Can we simplify more? Can I say 39 and 117 reduce? No. But what we could do is we can see if there's anything we can simplify. Can we factor out something from the top? 39 times 1 plus 2i over 117. Anything can go into both top and bottom? 3, right? 39 divided by 3, 13. 117 divided by 3, that would be 30, 39. That's interesting. So can we further simplify? Don't we see 39 before? Yes. So now divide both of them by 13. You got 1. Divide this by 13. You got 3. So we have 1 plus 2i over 3. But we need to put that in the a plus bi form. So we turn it into 1/3 plus 2/3 I. Next one, we want to solve this quadratic equation by completing the square. So let's refresh our memory. How do we solve the quadratic equation by completing the square? First, we are going to isolate the first two terms. So we got the x squared plus 5x, which is equals to 5. And now we are thinking of, hey, maybe we can add something on the left-hand side so that the left-hand side will becomes a perfect square. So what we can add? Maybe add the b squared. But what is b? How can I tell b is what? B would be half of 5. So it would be, next step, we add 5 over 2 square. And then on the left-hand side, it will becomes x plus 5 over 2 whole thing square. In the right-hand side, we got 5 plus 25 over 4. Then it will becomes 45 over 4. I have some sort of perfect square equals to 45 over 4. So what I could do is I could take the square root on both sides, and don't get a plus or minus sign will be generated. We can simplify the right-hand side. Radical 4 would be 2. But what about the radical 45? We can make it becomes 9 times 5. So that will give you negative 5 over 2 plus or minus 3 radical 5 over 2. And since both of them has the same denominator, we can actually combine them, make it becomes negative 5 plus or minus 3 radical 5, and the whole thing over 2. So far so good. All right, number 6, it's your turn. Let's try to use the completing square to solve this problem. Let's try that out. Let's see number 6. Do we need to separate them, put one thing to the other side? No, we already have two terms on the left-hand side. So we are thinking of, hey, what can we add onto the left-hand side so that it will becomes a perfect square? So what we could do, what should we add? We should add what? Add the b square. But what is the b? The b would be half of the 12. Now it's important that you recognize it's half of the 12. Don't just write 6, because by the time you go home you will not know how do we get that. And once we combine them together, that will becomes x minus 6 square, which is equal to 5 plus 6 square. That would be 36. Add them together is 41. And then after that, we can take the square root on both sides. And don't forget to generate the plus or minus sign. So because when we combine the the 3 terms together, it will becomes the x minus 6, the whole thing square. Add 6 on both sides, then you will have x is equal to 6 plus or minus radical 41. Now let's take a look at number 7. Work problem. Many of us don't like to deal with work problem. But if you look at that a little bit more often, well, it's really not that bad. What we need to do is we need to convert all the math in all the information into a math equation. We have the length of a rectangular storage room. So something like a rectangle. We have a rectangle here. And the length is 3 feet longer than its width. So if I let x be the width, then the length would be x plus 3 because it's 3 feet longer than its width. If the area of the room is 70 square feet, can we find the dimension? So the area would be equals to the length times the width. Would that be equals to, that would be equal to 70 square feet. So how can I get the x myself? Well, we can bring the x into that, and then minus 70 on both sides simultaneously. And the best way to solve this is by factoring. If we can we find the factor of negative 70? 1 times 70, 2 times 35, 3, no good, 4, no good. 5, yes. 5 times what? 14. How about 6? No. How about 7? 7 times 10. 8, 9. Nope. Then that's it. And which pair? Wait a minute. It's a negative, right? So one of them must be negative. So that means I'm looking for the difference. Which pair will have the difference of 3? The last one. And then I give the negative to which one? To the 7. So that they will add together equals to 3. So now I can actually read the answer. It would be x minus 7 times x plus 10. So from this, we can tell x minus 7 equals 0. So x is equal to 7. X plus 10, missing the 10, is equal to 0. Then x is equal to negative 10. Can x be negative? Can we have a negative length? So we need to reject this one. So x is equal to 7. Are we done? Not quite. They're looking for the dimension, right? What is the dimension? It would be the length times the width. So I know x is equal to 7. I also need to know what is the x plus 3. So that would be 10. So answer the question, therefore, the length of the storage room is what? Is 10. Is that right? Yes, it's a 10. And the width, yes, 3. Oh, but it's 7. Yes, the width is 7. The width is x. Okay. All right, number 8. Let's try that out. Don't just wait for me. Let's practice your number 8. All right, let's take a look. The area of the rectangular wall in a classroom is 280 square feet. The length is 2 feet shorter than 3 times its width. Find the length and the width of this classroom. Well, we got a rectangle. We should let the width be x. Always try to get the shorter one. Would let it be x, probably would be easier. The length is 2 feet shorter than 3 times its width. If I let width be x, 3 times x will be 3x. And now it's 2 feet shorter than 3x. So what's that mean? 3x minus 2. And we know the area is 280. So that means x times 3x minus 2 is equals to 280. So 3x squared minus 2x is equal to 280. Bring everything on one side. Then we will have 3x squared minus 2x minus 280 is equal to 0. Any common factor? No. Wow, then we will have to think about the AC method. What would be the AC method? Well, do you like to use the AC method? That's quite a lot of work, isn't it? We have 3 times 280. So the number is really, really big. What is the other alternative? Well, they don't have any GCF. So how can I solve this quadratic equation? Well, if you can factor them out, then that would be great. But this time would be hard because we have 3 times 280. So the number is real big. So what is the other alternative? We could use the quadratic formula. What is A? 3. What is B? What is C? Negative 280. So x is equal to negative b plus or minus radical b squared minus 4ac, and then the whole thing divided by 2a. So let's do the substitution. Negative 2 plus or minus radical negative 2 squared minus 4 times 3 times negative 280. And the whole thing over 2 times 3. So that becomes 2 plus or minus, wow, what would be the rest? I'm getting a little bit lazy. Let's consult our dancing shoes. We have, what do we have? Let me just close it up a little, right? We are going to have negative 2 squared, which is 4, minus 4 times 3 times negative 280. Hit enter. That turned out to be 3364. So we have a radical 3364 over 6. What would be the radical 3364? Would that be a whole number? Radical 3364. What would that be? 58. So that means it would be 2 plus or minus 58 over 6. So that really means we have plus or minus, right? So we have the 2 plus 58 over 6. That gives you 60 over 6. That gives you 10. You have 2 minus 58 over 6. And I'm going to reject this. Why should I reject that? Because it becomes negative, right? It's not possible the length would be negative. So x is equal to positive 10. And now, but don't leave it like that because we have x is equal to 10, but we also need to know the other. What about 3x minus 2? That would be 3 times 10 minus 2. That would becomes 28. So what is the length? Therefore, the length is 28 and the width is 10. Okay. Now without the calculator, sometimes the problem will becomes a little bit challenge, or sometimes will be way too challenge. Let's see number 9. You are given the formula. A is equal to P times 1 plus R over N raised to the NT. Find the accumulated value of an investment 8,000 at 7.5% compound semi-annually for 7 years. So let's take a look. A will becomes, what is the P? 8,000 times, open parenthesis, 1 plus, what is the R? R is what? 7.5%. So what's that mean? What would that be in 0.075 over, now if you don't know 7.5% is 0.075, well, you need to remember percent means what? Over 100. So you have 7.5 times, divided by 100, then you get 0.075. Over N, what is N? Would that be 7? It would be 2. Compound semi-annually. That means you have twice interest a year. So N is 2. And then raise it to the 2 times, what is T? 7. Now the rest will becomes a calculator job, right? So let's hold on to that, and we are going to do that a little bit later. Let's take a look at the last one. Can you set up the equation before we jump into the calculator? Let's try that out. All right, you have the next one set up. What would that be? A is equals to 800, 1500 times 1 plus 0.06 over what? 4 compound quarterly. That means they will give you 4 times interest a year. Raise it to the 4 times 3. So the rest would be the calculator job. All right, let's take a look. We have now practice. Many got the wrong answer by pressing the wrong key. 8,000 times, open parenthesis, 1 plus 0.075 divided by 2. Close the parenthesis, raise it to the open parenthesis, 2 times 7. Now, although many could say, oh, I know 2 times 7 is 14. Can I just put 14? Yes, but you should also learn how to use the calculator to handle every single things, especially when the number is getting big, right? Hit enter. How many decimal place do we need? 4? 2. This is money problem, right? So what should we say? 13394 point what? 41. Okay. So it would be 13394. Is that right? 94? 94.41. Okay, so every 3 digits, so it's 13,000 something. Okay. Can you try out the next one? So don't look at me. All right. Just try it out and then see if you got the right answer. Oops. Indeed, my calculator is down. You see how not reliable the technology. So you have to help me out to tell me what would that be. Are we done? Let's see. What would that be? 1793.43, including rounding. Is that right? Everybody got that answer? Very well. So it's 1793.43. So be careful. All right. Sometimes you must have a dancing shoe. Without the dancing shoe, it will becomes very, very challenging.